All right, we're going to switch gears a little bit and kind of look at how we can use molecular formulas to get information or lead us to various mass ratios of the atoms inside that molecular formula. And here's what I mean by this. So if we look at CH4, CH4, if we look at that, just that simple formula, one molecule of it, does that mean that since there's five atoms in CH4, that carbon makes up exactly 1/5 of the total mass? So if you have a carbon and four hydrogens, since there's five atoms, carbon must be 1/5 of the mass, right? No, that's not what that means. Carbon and hydrogen do not have the same mass. They don't have the same atomic mass, and so they contribute different percentages towards the overall mass of CH4. And we can see that if we calculate the molar mass of a molecule. So if we find the molar mass of CH4, one carbon, we look that up on the periodic table, has a mass of 12.11 grams per mole, or 12.011 grams per mole, and it has four hydrogens. So we multiply the atomic mass by 4. And so the molar mass of CH4 is 16.043 grams per mole. Now, if you look at those numbers, you can see right away, like, yeah, like hydrogen, even though there's four times as many hydrogens, it doesn't contribute four times as many mass. It still contributes a lot less mass than carbon does. And so this leads us to the concept of mass percent. Mass percent is the mass of a component, or if you want to look at it in terms of a molecule, it's the total mass of an atom or atoms divided by the total mass of the molecule. And then we multiply it by 100 to put it into a percent. So if I'm going to do this for one molecule of CH4, I can find the mass percent of hydrogen by taking its molar mass. So notice that that's the total, like all four hydrogens, divided by the whole molar mass of CH4, and then multiply it by 100. Notice that the units cancel out, so this is a unitless calculation. And we get to 25.13% of CH4 is hydrogen. And I can do this for carbon as well. So the molar mass of carbon is 12.011. Again, there's one carbon, so I don't have to multiply it by anything. And I divide that by the total mass of CH4. Multiply it by 100 to put it into a percent. And I can see that 74.87% of carbon, or CH4, the mass of CH4, is 74.87% carbon. Now, in theory, all of your mass percent should add up to 100. It might not add up exactly, it might be off by like maybe a tenth or a hundredth of a percent because of rounding. We got to keep track of sig figs. So sometimes that rounding leads to something that's not exactly 100%, but it needs to be really, really, really close for any sort of compound. So let's kind of put this into practice here. So a 12.04 gram sample of a liquid compound contains carbon, hydrogen, and nitrogen. And then here are the amounts that they found for this compound to contain. So what is the percent composition of this compound? Let's just start with carbon. So we're given 7.34 grams of carbon. and the total sample is 12.04 grams of the sample. Multiply it by 100 to put it into a percent, and that comes out to 61%. I'll do the same thing for hydrogen. So there was 1.85 grams of hydrogen found to be in the sample, and the sample, again, same value as 12.01 grams. And I toss that in the calculator, comes out to 15.4%. And then finally, for nitrogen, it's found to have 2.85 grams of nitrogen. And I'm going to divide that by the whole sample times 100. And that comes out to 23.7%. Now, if I check my answer and I add all of that up, that gets really close to 100%. I think it's like a tenth of a percent off because of rounding. But that's a good way to check your answer, is to add up all the percentages, and it should add up to 100% or very, very close to it. Now, we can use these mass percentages as conversion factors. So in this problem, it's asking us how many grams of hydrogen are in 18.2 grams of CH4. Okay, now in order to answer a problem like this, we have to find the mass percent of hydrogen first. So we got to do that. Now we kind of did that a couple of problems ago. I'm going to do it again just so that we get the practice on this. So I want to find the molar mass of CH4. So again, that's 1 carbon. And I have 4 hydrogens. So add all that up. The molar mass of CH4 is 16.043. Now to find the mass percent of hydrogen, in CH4, I'm going to take hydrogen's molar mass. So again, that's multiplied by 4 because there's 4 hydrogens in the formula. And divide that by the whole thing, the molar mass of CH4. And that comes out to 25.13% hydrogen. Now, what that means is 25.13% of this 18.2 grams is hydrogen, and the rest is carbon. And so I'm going to use this percent here as a conversion factor. Well, how do I do that? I do it just like the other units of concentration I've looked at earlier. I'm going to say, well, 25.13 grams of hydrogen are in 100 grams of methane. That's what that 25.13% means. So I can set up my conversion factor to go from grams of methane to grams of hydrogen by using my mass percent. 25.13 grams over 100 grams of CH4. Notice grams of CH4 cancel out, and that comes out to 4.57 grams of hydrogen. All right, so again, it's very important that first of all, you know how to use these mass percentages as conversion factors. And that's going to allow you to solve problems like this very easily rather than trying to wonder, well, where do I even start? When we're talking about how much mass makes up a particular compound or an atom makes up in a compound. We need to know the mass percent. And that will be the necessary conversion factor in order to accomplish a problem like that.